What the... Yeah, stupid night shift. Hello, Internet. My name is Quinn, and this is Blondihacks. I'm back on the Pennsylvania A3 switcher this week, and I've got a bunch of trim and detail pieces around the tender water tank to make before we can really call the water tank finished. So let's go. When last we left our tender, it was certainly structurally sound, however it has a distinctive wobble to it. Needs a little bit of flattening after all of this soldering that we did to it. I'll put it over the surface plate just to make doubly extra sure, and in fact, the wobble got a little worse once it was disconnected from the heavy base plate. Not terribly shocking. I'm going to flatten this on the belt sander. I got to remove the stopper foot thing because there isn't space otherwise. I've blued up the bottom edge so I can see where material is being removed, where the low spots are, and so on. And well, let's give this a whirl. I was thinking about doing this on the milling machine originally, perhaps with a fly cutter or something like that, but my patrons actually talked me into doing this on the belt sander instead, on the assumption that the structure was likely to get snagged by a milling cutter. So I took their advice and decided to do this on the belt sander. This seemed to work fine. Took a little bit of checking and sanding and checking with my bluing to make sure that I wasn't removing too much in one area and that I was getting all of the high spots removed. And that is starting to look pretty good. You can see where the blue is left on this corner that I knew was low. So I continued with this until the bluing told me that it should now be flat. I'm going to check it over on this workbench, which is brand new and should be the flattest thing, large enough to test it. My surface plate's really too small for this. And that seems to have done the trick. There doesn't seem to be any perceptible wobble in that. So far, so good. Now, whether it's flat or not is a different question. So for that, I'm going to assemble it on the base plate, and I'm going to get some light on the situation. I'm going to put a light in there and check for gaps underneath the sill, between the sill and the base plate. Those, of course, will be water leaks. Now, this thing is going to have a gasket under it, so a little bit of space here and there is okay as long as we're within gasket range. I do have one low spot right here that would take a lot of sanding to get rid of, and I don't want to necessarily do that, but it looks like that gap is within gasket range, so I'm going to leave that one. And everywhere else actually looks good. The tank is attached with a gasket rather than just soldering it in place because it has to be removable for servicing a water pump that lives inside this tank. On now to the outer trim panels. The plain copper sides of the tender get covered with these brass plates that have a decorative rivet pattern on them and hold the lettering for the livery. These are just decorative, but they really do add a lot to the look of the tender. This layered approach creates some nice shadow lines on the corners of the tender, but also it allowed us to use more bendable copper for the tricky radii on the corners of the inner tank, but then the outer tank where the rivets go is more durable brass. I started by CADing up a template that was to the drawings, but I don't expect these to be perfect fits because I don't think my tender is exactly to the drawings at this point. There's been enough fudging along the way. It's close, but it's definitely not perfect. I made a few fine adjustments to the paper. I'm looking for just something that looks right. It just needs to look like there's an even margin of copper all the way around the brass plate. And the tail end was also a little bit short. I guess my tail end is still a little bit longer than in the drawings, so I added a little piece there and then recut that to be a nice fit. And that looks good. Once I was happy with that, then I can move on to transfer this onto brass. It's worth noting left to right, they are very slightly different as well. There was maybe 10,000ths of height difference left to right, so I modified the template a little bit for the other side, but they're pretty close, which I'm pretty happy with. Being decorative and not needing to fit up against anything else with extreme accuracy, then just tracing to a paper template and cutting and filing to the scribe line should be sufficient here. I started by cutting that end off of this piece of brass stock because the other side piece can come out of the opposite corner of this same section. That saves a lot of waste on this part. I wasn't quite able to reach all the way to the end of every line on my bandsaw. The throat on this saw is a little bit limited, but I was able to get most of it, and then I finished it up with a hacksaw with the blade turned sideways. Based on how rarely I see people do this, this may not be a commonly known thing, so in case you haven't seen this trick, most hacksaws will allow you to turn the blade 90 degrees for making cuts in deeper material that otherwise wouldn't fit in the throat of the hacksaw. It's especially helpful here because the hacksaw blade has the same curve as that portaband blade. I couldn't come in and finish this cut with a jigsaw or any of the other million ways people always tell me to do this, because those other saws have a thicker curve. And also, I hate cutting sheet metal with jigsaws. Please stop suggesting that. 3 of the edges on these pieces are square and straight and parallel to each other, respectively. So those are easy to do on the milling machine. Might as well. Got this sheet metal milling setup that I developed for the boiler originally, and it's come in handy all the way through this build for these large sheet metal pieces. You can also file these edges, of course, but once you've got a setup like this, milling them is honestly quicker for me, and it leaves a really, really nice result. And the great thing about milling these edges is that then you know you've got a really straight and or square edge that you can use as reference for other fitting operations on that piece of sheet metal. I found that to be extremely helpful. For the angled side cuts, I didn't know exactly what that angle was, and setting that up would have been quite a bit more work, so these edges I did in fact just file down to the lines. Using the milling machine for this kind of stuff is kind of cheating. If you can't get straight edges with a file, the old-timers would say, get better at filing. When I think I'm close, I start test fitting. The brass base plate on the tender sticks out one material thickness wider than the copper by design, so this brass trim piece is actually sitting on that lip, which makes a perfect vertical reference. So all I'm doing is lining it up such that the reveal of the copper looks the same all the way around, and then fine-tuning the shape. Once I'm happy with that, then it's time for our old friend, the rivet pattern. I made paper templates for these just like the other pieces that you've seen. The catch with these pieces is that they were too big for one sheet of printer paper, so I had to split the template across 2 pages with registration and alignment marks. Did my best to line them up and tape the pieces together, but I did have a little bit of inaccuracy introduced by that. I think it worked out okay, but you'll see how it goes. Once again, my old friend Super 77 spray glue. What's nice about this stuff, in addition to being easy to remove as long as you don't use too much of it, is it gives you some working time. And with a tricky, large template like this, you don't always necessarily get it down perfectly the first time, so you can pull it back up and readjust it. It's not like contact cement or other adhesives where you get one shot to get it down perfectly. Super 77 is really quite forgiving. And as you can see, the edges don't line up as perfectly as my other templates did. But that's okay, because the rivet embossing tool that you've seen lots of is going to be the arbiter of the critical dimension, which is the distance between the rivet and the edge of the material. The paper template is, once again, just a guide for the horizontal spacing of the rivets. And for that, the paper template does not have to be applied that accurately to the brass. So as I go along, the material is up against the fence to make sure that that distance is consistent, and then the template is giving me guidance for horizontal spacing. And these don't have to be absolutely perfect. As myself and many commenters have pointed out, these locomotives weren't perfect either. They were built largely by hand with hand tools, aside from the machined parts, of course, so they are far from perfect. If you're ever feeling bad about your model, go put a square up against any part of a real steam locomotive, and you'll feel better. There are no mistakes in modeling, only added verisimilitude. Just like on the prototype, there's horizontal rows of rivets down the centers of these panels that are lower density than the edges. And if you're new to model railroading and or model engineering, the word prototype is a goofy word that modelers use to refer to the real thing. And this is why curling has the most application to real life of any sport. So put down those soccer balls, rest of the world, or whatever Americans do, and come on out to a bonspiel. You'll learn useful life skills. By now you've seen this a lot. I've drilled out some of the key rivets and replaced them with fixturing screws to attach the brass plates to the copper panels. The difference here is these brass trim panels do not get soldered on. They're just held on with the brass screws. They aren't heavy and there's nothing structural, so soldering them on would be kind of a waste of effort. Kozo says in the book that they are also thus removable if you want to change the livery of the locomotive, but I can't imagine ever wanting to do that, and they're going to be painted in place anyway. I spaced out these screws wherever they looked like the panel needed them, based on where the panel wasn't sitting tight against the copper naturally, and I did these by match drilling them in one setup with the panel taped in its final position, so this went pretty quickly. Once I thought I was done, then I removed all the clamps and everything and made sure that the panel was sitting nice and flat all the way around. I did find I had to add one screw on each panel. There was one spot where they weren't quite sitting flat, but otherwise that went very well. These side panels really add a lot. They're really quite nice. I think my rivets aren't quite as deep on the side panels as they are on the top. Maybe it's just the way the light catches them, but I may not have had the embossing tool set up at quite the exact depth that I used before, but I'm happy with the result anyway. Once this is all tied together with paint, I'm cautiously optimistic that it's going to look really good, especially with the livery lettering on the side there between those two rows of rivets. This is also the moment of truth for that corner repair that I did. You might recall I did a whole video on repairing this corner. If I did my job right now, the only part of this repair that's still visible is smooth to the touch, so it should completely disappear under paint. And if it doesn't, it's just part of the story. We'll say that's where the night shift backed it into the water spout. That night shift, they're so clumsy. Next up is an angled platform that sits on the back, and it holds a light. It's, I think, a rear-facing work light, but it's also identical to the headlight on the locomotive. So I think the idea was that the crew could swap them if the headlight failed. It's a rectangular frame made of bar stock that's a bit of an odd dimension that I wasn't able to source, so I'm going to mill down this rectangular bar stock that I do have to suit the dimensions needed. Essentially, I'm making 4 pieces of custom dimension bar stock that are going to be cut apart and soldered into the rectangular shape. So once I've got the entire piece milled down to dimension, I've left it a little bit oversized on one dimension. You'll see why in a moment. And then I can cut apart the pieces, clean up each end of each piece, and bring them all down to length over on the milling machine. With all 4 pieces brought to length, I should now be able to assemble them into a rectangle, and that rectangle should be the correct dimension. And that is looking good. Now I'm going to center up one piece on the end, one of the short pieces, and I'm going to center drill and tap for some fixturing screws that go in the ends of each of the short pieces. I've done this with an end stop so I can quickly run through all 4 ends of the short pieces. Then using a similar setup, but this time horizontal, I drill clearance holes through both ends of each of the long pieces. In this case, I use a setup arranged for one end, and then I can flip them end for end because, of course, they're symmetrical end for end, so I can do all 4 ends quite quickly this way. End stops are extremely powerful for efficiency. There's my 4 pieces. Now if I did my job right, I should be able to screw them all together, and the final assembly should be the correct dimension in X and Z, and everything should be nice and flat and parallel top and bottom. All the outside edges should line up, and that is all looking good. Then everything gets pickled and reassembled with flux in all the joints for silver soldering. This technique of silver soldering up an assembly and then machining that structure, kind of like building a casting from bar stock, is something that Kozo does extensively on this locomotive build. I'm sure it's a common technique in model engineering. For some pieces like this one, which aren't really that big, a very reasonable question is, why don't you just mill that piece from solid bar stock? I think you certainly could. I think if I was going to do this piece again, or should I say a third time, I probably would mill it from solid bar stock. That might be easier, but you don't always know when you're just looking at the drawings ahead of time which way is going to be easier. Kozo always does these small silver soldered assemblies, I think because he's using, at least as of the writing of this book, he was using a 3-in-1 machine, so not a very capable mill, and thus setting it up is quite difficult and time consuming, and he's not really assuming you have a mill for this build, or not much of one, and so he expects you to do a lot of this kind of thing with fret sawing and filing. And if you're doing that, then an assembly like this is much easier to work with than milling from solid bar stock. All that said though, everything gets cleaned up once again, and now I can file off the heads of the fixturing screws. Then it's back over to the milling machine to put the first of 2 bolt patterns in this thing. This bolt pattern goes on one side and it holds a plate that the work light / spare headlight sits on. While in this setup, I also skimmed a few thousandths off this side just to make sure it's really nice and flat. Remember, I left it over dimension on this dimension specifically for this reason, so I can make sure I can flatten it, but also for another reason, which is that we're about to set up for an angle cut. I'll zero my digital level on the base plate and then go from there to measure the slope of the back. And it looks like it's exactly 16.95 degrees. So that's the angle I need to cut on the bottom of this frame so that the frame will give a level platform for the work light to sit on. Re-zero the level on the vise now, and I can set the piece at 16.95 degrees in the vise. These digital levels are really great because they allow you to measure relative angles and easily transfer those angles to a different scenario, which might have a different base level for the entire structure, in this case the milling machine. With the low end tapped against the parallels to make sure the piece is sitting square in the vise, I can now tap in the high end until I get to that 16.95 degrees. Very carefully sneak up on it. And perfect, 16.95. So if I mill it flat in this position, then I should end up with a structure that will end up sitting level on the back of the tender. The high end gets milled all the way down until it comes out flat on the low end. I'm taking light cuts because this setup is not super rigid. You know, this is a hollow frame that's being squeezed in the vise, and half of it isn't really in the vise jaws, so not the most rigid setup, and I don't want it to move. Taking my time, light cuts, and that paid off. I got a really nice, clean surface on that. That was a lot of steps to get to this intricate structure, but it couldn't have gone better. Or so I thought until this moment. Actually, that couldn't have gone worse. Yeah, everything went perfectly until this final step. Do you see what I did wrong? Because I did just as I was shutting off the milling machine. I cut the angle the wrong direction. It's supposed to go along the short side of this piece, not the long side. Yep. Well, since we're here anyway, I might as well check my setup and see if that angle came out right. And, whoa, look at that. All zeros. Beautiful cut on a worthless piece. Yep. To keep from getting discouraged in moments like this, always remember one thing. You can make it again in half the time that the first one took you. It took most of a day to make this first one. The second one took 3 hours. You've done all the math, you've figured out all the setups, you've chosen all the cutters. All that little stuff adds up that you don't have to do the second time, and it just really goes much quicker. So keep that in mind, keep your chin up, make it again, won't take that long. Second bolt pattern gets drilled on this side to match the one in the tender. This one is slightly off center so that the two bolt patterns don't collide with each other, and the threaded holes are at different angles, which is quite interesting. And here is the final part. With that practice piece out of the way, I gotta say the second one went even better, and that came out beautiful. Let's give it a little test fit, shall we? It looks good. Let's see if it's level. Survey says, oh, poop knuckles. It's off by half a degree. So not quite as perfect as the first one was, but we'll say the night shift backed something into that too. Onward to a plate that mounts to the top of this to give us a little platform. I scribed it a bit oversize on the piece of brass, went over to the bandsaw, rough cut that out, and then milled up all the edges to make them straight and square on the milling machine. Then this plate gets a bolt pattern drilled in the top of it. This is a very quick and easy operation. I think this whole piece only took a few minutes. Very easy. For a test fit, I put some studs in the bottom of it. It's supposed to be screwed in from underneath, but that requires removing the water tank, which I really don't want to do. There's 18 screws in that thing. So I'll set it in place with these studs for now. Give it a little test fit with the mounting plate that goes on the top. I don't have the right screws for this. They're supposed to be countersunk flathead screws, but I can't find countersunk brass screws in the 164 thread. I've looked everywhere, so I'm not sure what I'm going to do there yet. I don't want to solder this plate in place because that would make it so you can't remove the headlight off of here without dismantling the entire tender. So I do want it to be screwed in from above. I'm not sure what I'm going to do there yet, but let's check if it got straighter. Nope, stupid night shift. Next up is the coal stopper, which is a little vertical piece that keeps the pile of coal from sliding out of the tender when I guess you slam on the brakes or, gravity or bumps or whatever. It's a coal stopper. It stops coal. This is made up of 3 little pieces. These little legs get bent to 90 degrees, and then they get soldered into the backstop plate. A little mock-up here so you can see how this is supposed to go together. These little legs need to be soldered in this position. The trick is making sure that everything ends up vertical, that the legs are in the right place, and that the spacing ends up correct so that it will bolt to the existing hole pattern in the base plate. To do that, I decided to set it up in situ, and I'll clamp the legs in position once everything is where it's supposed to be. I figure this way I can guarantee that the hole pattern is going to still line up after I've soldered everything together. Things have a strong tendency to move and shift when you solder them, so making sure hole patterns end up consistent at the end is always the trick. With everything centered properly and clamped in final positions, then I can remove those screws and take this whole assembly over to the milling machine, and I can drill some solder fixturing screws in position without moving anything. The setup was a little sketchy, but these are very, very tiny drills with very low cutting forces, so I got away with this. I drilled and tapped 2 number 0 fixturing screws in each foot. That might have been overkill, but when you can do all 4 of them in one setup like this, it really doesn't take that long. and it potentially saves you scrapping the part, because if one of these legs moves during soldering, well, you're pretty much done. You got to make everything again. So in my experience, it's well worth going overkill on the fixturing screws. Every time I put in fewer than I think I need to, or I get a little skimpy or lazy with them, I always regret it. Then once again, all the parts spend 5 minutes in the Sparax No. 2 pickling acid, because people always ask, and then it gets reassembled with flux and the fixturing screws, and then over to the hearth for silver soldering. You know, pieces like this could probably be soft soldered. Kozo does a lot of silver soldering of these small assemblies, which is probably overkill. A piece like this is not exposed to any pressure or high temperatures, so honestly, silver solder is probably overkill. I'm not exactly sure why he leans so hard on silver solder. It might be for pedagogical reasons, because again, this is supposed to be a beginner's book that builds your skills as you work through the book. So he might just be trying to give you as much silver soldering practice as possible so that when you get to the boiler, you're pretty good at it, because of course on the boiler, it really does matter. This piece went okay. The top joint didn't work out. The solder flowed over the leg. It didn't flow down into the joint. My angle wasn't great on this piece on the setup, but I was able to quickly put another piece of solder in there before everything cooled down and the flux spoiled, and just flow that again. That worked out fine. I might not have tried a stunt like that on something like a boiler part, but on the coal stopper, it's fine. After that gets cleaned up, I can do a test fit, make sure nothing moved, and that is looking really good. I left the legs overly long, just in case the bends ended up in the wrong place, so that I could trim to length as needed. And so now I can do that, and I can file the excess length off the top of those legs. That looks pretty good. Now I've got a bunch of excess solder, and those bolt heads need to be filed off, so I will do that next. And a little quality time with a needle file to tidy up some of the corners and make sure there's nice smooth transitions everywhere, make sure there's no excess solder sitting in the corners, that kind of thing. The final detail on this coal stopper is a corner radius on each of the corners. I can't use any of my many corner rounding fixtures for this because there's no reference hole at the center of the radius like there often is on parts. So these I just traced with a radius gauge, and I will file them by hand. As I always say, the secret to filing smooth curves is to drop the handle on each stroke, so the file is describing the reverse curve that you're putting on the part. That's how you avoid flat spots. I point it out every time I do it because this is the number one thing that I see people do wrong when filing, especially if they're new to metalworking. It's an unintuitive way to create a curve, but it's actually the better way. It's actually easier too. Once you get the hang of it, it's a smoother motion for your arm. You'll be amazed what nice curves you can create by doing it this way. That is looking good. So put a nice radius on each corner, then a little bit of cleanup, and here is the final coal stopper. Sometimes these little parts just really end up pleasing me the most. I'm quite chuffed at how that turned out. It's a nice looking little part. When that's painted and the solder and the brass and everything all blend together, it's going to look really nice, I think. I'm going to mount it in its final position, but again, I don't have the right screws for this. These should be pan heads, not these flathead screws. I've got the correct screws on order. In this case, I can find them, I just don't have any. So that'll do for now, however. And that is looking pretty sharp, I think. And that's a coal stopper. There it is, a whole round of new details for the tender. The tank sides, I think, are looking especially sharp. I'm looking forward to getting the lettering on there, really make it polished and final. This whole thing is going to look great, I think, once it's painted. That's really what's going to tie everything together. If I do a good job on that final coating, then it's going to instantly transform from a collection of random brass and copper parts soldered together into a beautiful, cohesive structure. But it's certainly looking more tendery by the day. I hope you agree, and I hope you enjoyed watching this process. We've got lots more fun detail parts to make on this yet. I really enjoy the detail stuff much more than the big sheet metal parts, so stay tuned for all of that. We're going to be making stairs and handrails and ladders and all kinds of fun stuff on this. Lots more to go before we can call this a tender. But it's certainly looking the part, and it gets heavier all the time, and the heavier it gets, the smoother it rolls. It's really quite thrilling. Once again, I sit here for much longer than I'm prepared to tell you, just pushing it back and forth. Thank you very much for watching. Thanks especially to my patrons who make all of this possible and keep this content ad-free every single week. You are the best, and I will see you next time.